Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem number of nodes in subtree with same label. In this problem, we are given with a tree. Tree is nothing but tree will be connected, undirected, and will have no cycles. The tree consists of n nodes numbered from 0 to n minus 1 and exactly n minus 1 edges. The root of the tree is node 0 and each node of the tree has a label which is a lowercase character given in the string labels. The node with the number I has a label of I. The edges array is given on the form edges of I equal to AI comma BI, which means there is an edge between AI and BI in the tree. Return an array of size n where answer of I is the number of nodes in the subtree of ith node which have the same label as the node I. So this is the main aim behind the problem. And a subtree is a tree T. Is the tree consisting of a node in T and all of its descendants. So what is the meaning? If we are at this node, what will be the subtree of this node? We consider this current node and all of its descendants. So this entire thing will be the subtree. So what we are asked in this problem, we are asked to return an array of size n where answer of I equal to number of nodes in the subtree of ith node which have the same label as the node I. Let us take a look at the example. So we are given with number of nodes, edges, and the labels. So this is the tree. If we are at node 0, what we have to count? We have to count number of nodes of the subtree of ith node which have same label as the node I. So what we have 1, we consider itself in the subtree. So we have 1 and we don't have here 1 A we have here. So total number of A's are 2. So for 0, the answer will be 2. And let's come to 1. At 1, we have a label as B. In its subtree, in this entire subtree, only we have 1B. So answer of 1 will be 1. For all the other nodes, it will be same. You can check out other examples as well. Let us see how we can solve the problem. So I have considered this example and I have also taken the answer array here. Answer array is the array which we have to finally return. And what we have to do here, we have to perform a DFS traversal. So we start DFS from root node 0 and we go to its adjacent node. And then from 1, we go to its adjacent node 4. So at 4, what we have to do is, in DFS, what is our final aim? Our final aim is to calculate the number of nodes in the current subtree with same label as node I or the root of the subtree. So what will be the subtree? The subtree will be this. And it doesn't have any descendants. So in order to keep track of what are all the labels present in the subtrees, we have a frequency array. So at each node, we will have a frequency array of length 26 because the labels are lowercase English characters. So to represent them, we have a 26 length frequency array where we map A to 0 and B to 1 and so on. And here we have A, B, C, D, and E. So since it doesn't have any subtrees, we only count the current nodes count and it will be 1. So what will be the answer for this entire subtree? Since we only have 1D in the subtree, the answer will be 1. And now we return back this frequency array to B, and B also has a frequency array. So A, B, C, D. And B updates this frequency arrays to its frequency array. So it increments the D value here. And now it again calls DFS of other adjacent nodes. So we have other adjacent node as C, 5. So it calls DFS of 5. 5 doesn't have any children node. So it only adds its frequency to the frequency array. And what will be the answer for 5? For 5, we have only one node in the subtree and it has C. So the 5 answer will be 1. And we return back we return back from 5 we return this frequency array and it updates. B1 updates its frequency array with the 5 frequency array. So finally, it also has to update its own label frequency. So it updates B to 1, and this is the final array at B. So now how many B's are present in this subtree? There is only one B. So the answer of 1 is 1 itself. And now we return back this frequency array to 0. So, and then from 0, we again go to the other adjacent node 2. And from here, we go to here. And 3 will also have another frequency array. So 3 has only one node, so it updates its frequency. And what will be the answer for 3? Since we have only one node with E, we update the 3's answer with 1. And 3 return back the frequency array to 2. And 2 also has a frequency array A, B, C, D, and E. It updates the frequency array with the frequency array which it got from 3. So we update it. And 2 again calls 6, DFS of 6. Since we only have one node in the subtree, it also has a frequency array A, B, C, D, E. It counts itself and it return. What will be the answer for 6? Answer for 6 will be 1 because we have only one node in the subtree and it's D. So we increment it. Answer will be 1. And now we update the 2 frequency array with the frequency array which we got from 6. So what will we have to increment D. And now we also have to consider the current node's frequency. So we update for A. And so what is the answer here? Answer for 2 will be how many A's are present in the current subtree. The only one A is present. So answer for 2 will be 1. And for finally, for 0, we also have one frequency array A, B, C, D, and E. We have to update both of these frequency arrays here. So first we do for 1, 1, 1, 1, and we also have to update with this. So for A we have 1, for B we have 1, so B will become 2 now, and for C we have 0 over here, and for D we have 1, so D will again become 2, and E will become 1. So number of A's present in, wait, for A also we have 1 here, right? So we have to update A. For B we don't have anything, so B will be 1. This will be 2, this will be 1. 2, 1, 2, 1, 1, 2, 1. So how many A's are present? There are 2 A's present in the entire subtree. So we will have answer of 0 as 2. Sorry. So this will be our final answer array, and we return this array. So let us code it up. I forgot to record while I was coding it up. So here we are. Let me explain you the code. So firstly, we are building the adjacency list from given edges. We are taking map of list of integer adjacent, and we are adding all of our edges to the adjacency list. And then we are initializing the answer array, and which we are going to return finally. And we are calling a DFS function with the root node. We are passing the parent as -1, and we are passing n value, adjacency list, answer array, and labels string. And here we are implementing the DFS function. Each node will have a frequency array. So we have named it node counts, and we are updating the current label to our frequency array. And then we are going through all our neighbor or adjacent nodes. We are checking if neighbor is not equal to parent. If neighbor is equal to parent, we don't consider it as our subtree, right? So we we check it over here, and then we apply DFS on our neighbor, and we get its child counts or its frequency array, and we update our current frequency array with child's frequency array. And finally, what will be the answer of current node? Answer of current node will be what will be it? Number of nodes in the subtree of ith node which have same label as node I. So node counts contains the node counts contain the frequency of all the labels in the current subtree. So for that we pass label of current node. It gives us the number of times the current node's label is repeated in our subtree. So we take it to our answer, and finally we return the current frequency array to our parent. What will be the time complexity? The time complexity will be O of n into 26, because for each node we go through each node once, and we are also performing this loop which runs for 26 times. So time complexity will be O of n into 26, and space complexity will be O of n into 26 as well, because for each node we are having a array for counting the frequency of the labels in that subtree. So both the time complexity and space complexity will be O of n. The problem is little tricky to explain because there are so many things to keep track of, but I hope I made you understand it. If you did understand today's solution, make sure you hit that like button, and for more daily videos, to subscribe to Coding Charms YouTube channel. Keep practicing. See you all in my tomorrow's video. Till then, take care. Bye bye.